In this video, we are going to continue our discussion of planes, lines, and points in 3 space by asking ourselves how to find the distance between a line and a point. So on the screen, I have a point and I have a line. We're going to do some analysis to come up with a formula here. Okay, so I have point P. I'm going to pick any point Q on the line. First, let's talk about the distance from that. We know that the distance from a point to a line back in high school geometry is the vertical distance. Trying to figure out where that's straight. There we go. It is that distance there. We are looking for this distance. Let's call it lowercase. Okay, that distance there. I could pick any point on the line Q to help me do this. So P was the point given. Q is the point that we would just come up with, and you can put this anywhere. I can create a vector from Q to P. I'm actually, forgive me if you're using, I'm going to flip these. Actually, let's leave it alone. All right, so we'll leave it like that. Okay, so a few things here. We can come up with theta. Let's call another vector of the line that we're going to be able to grab if they gave us a line is we would have a directional vector. And we'll let it be all the way across just here. Make this a little thicker. All right, so that's vector V. That is the directional vector of the line. We'll call the vector that we created between Q and P, we'll call it U. All right, we have all this stuff now, and we'd like to come up with something to solve for letter D there. Notice we have a right triangle by definition of distance between a point and a line. We can use this right triangle to come up with our formula. So if I do that, I see that if I'm using the vertical distance, that's going to be sine theta equals D over, and then be careful with this is the magnitude of that vector U. Remember, U is not a distance, it's a vector. So that tells me that distance is equal to the magnitude of U times sine theta of that. Now, this isn't that helpful because I'd have to come up with that U, and I don't really want to deal with theta because that means I'd have to find U, come up with a U, come up with a theta, and come up with all that. So I'd like to come up with a better formula for this. This is going to be some algebraic manipulation. You may not see why we're doing it up front, but we're going to use a formula and we're going to make it happen. So I'm going to times both sides of that equation by vector V, magnitude. Now, I hope something in your head is like, hey, something's up on that right side that looks familiar. Well, yeah, it is a formula from a few sections ago. This is actually equal to the magnitude of the cross product between the two. U, remember, would be some vector we created from the line to the point. We'll have a point that we can pull from the line, and we'll have the point in question. We can create a U. V is the directional vector from the line, which should be given with the line. I can now solve for distance here, which gives me U cross V magnitude over the magnitude of V. So there's the distance between a line and a point. I don't recommend memorizing these. I recommend thinking through it every time if you can. That's how I have to go about it every time I do these. I'm just bad at memorizing formulas. You'd think I'd be great at it since I teach this course 3 times a year, but they just don't stick. So deriving, I think, is the way to go because I could not see this formula for 8 months, draw this picture, and find the formula. If I can remember this to that. That's the kicker. That is a memorization technique there. Okay, well, I have an example of this to end it all in this video with. So find the distance between the point and that line. Okay, so I need this kind of what I was talking about. Okay, I have this line. This is line L, what we just talked about. This is point P. And this is how I go about, okay, I need this distance. And I have that. Okay, this is going to be some other point that I'm going to find. Okay, so point Q is going to be from that. I can actually find Q from the line itself. Those numbers that are in being added and subtracted to my variables give me my variables. So we'll call this point Q. That'll be point P. And I need U. and I need v to use the formula. Okay, I could derive it all again. I'm going to save you time on the video and not derive it twice with numbers. I'm just going to use the formula. So the distance, I need a u, so let's do that. U is going to be the vector qp. So -3 minus 1 is -4. 12 minus -1 is 13. And then 5 minus 3 is 2. So I have that. I also need the directional vector of the line, which is my denominators of that line. I got 4, -3, 6. Right? And then I have the distance is, if I look at my formula right above, I need the cross product magnitude. I also need the magnitude of v. So let's do the magnitude of v first. That's easier. Magnitude of v is going to be, use my calculator, feeling lazy. The square root of 61. Okay, now I need to cross them. Take me a little bit here. Got I, j, okay. All right, u would be -4, 13, 2. V is -4, 4, -3, 6. All right, I write out each definition here. So we got 13, -3, 2, 6. That's I, minus, I cover up j and write down everything there. Almost wrote down the wrong one, 2, 6. That's j, plus, and then cover up the k column, write down everything else. Okay. Okay, now we multiply. 13 times 6 is 78, plus 6i, minus -24 minus 8j, plus 12, minus 4 times 13 is 40, plus 12 was just 52k. And then we have our vector here, that is 84. That's positive 32. And then 40, -40. All right, so that is that thing. I also need the magnitude of u cross v. So the magnitude is going to be quite large, I bet. So I'll do this one in my calculator. 84 squared plus 32 squared plus 40 squared is 9680. Let's see if that goes down any nicer. It does not, so we'll leave it like that. So the distance is that number over the square root of 61. So we have divided by the square root of 61. Okay, and it doesn't work out cleanly for me. This is roughly 12.6 distance away. So there's my answer. Okay, this one's a bit rough because it's cross product always. I hope that's speeding up for you. I know I move pretty quick through my cross products in my video now, and I will move pretty quick as I go through them because I don't want to use too much video time on an old skill. I will show every step so you can check your step. Also, to point out, there may be arithmetic mistakes here and there in my videos. Please just ignore them. If I make anything foundationally wrong, I usually re-record my video. But if I accidentally add two numbers wrong or divide wrong or something like that, I keep going. I don't know if that happened in this video, but I had that thought. So keep chugging along.